Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to Pyramids and Cones, where once again I have known my limitations and did not try to draw them. I will say that when I drew them on the original paper, it took me about 20 minutes to get everything situated just so with my stencils that I use. As you can see here, I have drawn a rectangular prism and a cylinder in blue. And a cylinder is a type of prism because that has two parallel faces. And inside them, I have drawn something that comes to a point. In this case, it's a cone. In this case, we call it a pyramid. So what we can tell right there is that they just don't take up as much space as their relative counterpart for when they have parallel faces, because I gave them the exact same base. So their volume is actually less. In fact, it's exactly a factor divided by 3. So if you have to calculate the volume of these, it's going to start off the same way as what you did for a prism. You're going to take the area of the base, multiply it by the height, but because it comes to a point, you're going to divide it by 3. It's the only difference between doing the volume for when it's a prism versus volume when it's a pyramid. The point makes you divide by 3. So let's give it a shot. I'm going to draw a triangle right here. I'm going to come over here. We're going to connect. Okay. I'm going to tell you that the height from here to here at a right angle, because I'm very bad at drawing, so I'm going to tell you that's the actual height at a right angle, is 12 inches. Okay. The triangle of itself has a base of 7 inches and a height of 2 inches. So it's triangular, which means we have to do 1/2 base times height. Then it's a pyramid, not a prism. So we're going to times it by the pyramid height divided by 3. And the divided by 3, you can have it written, you'll see it this way as well. 1/3 capital B, because that's area of the base, H. So you'll see it written like that as well. Okay, we're just going to type it in the calculator. Remember, this divided by 3 is because it comes to a point. That's that extra step because it comes to a point, and so it uses less. So 7 times 2 is 14. Half of that is 7. 7 times 12 is 70, 84. Divided by 3 is 28. So we have 28 cubic inches. Again, it's a 3-day shape. So what happens when we put shapes together? Because honestly, making a video about just pyramids and cones is like, hey, you know that video about doing volume of prisms? Just do the exact same thing, just divide by 3, because that's really all you need to know. What if this right here were the shape of your grain bin or your water tower or whatever? We've got this shape that is a prism type because it's a circular base not coming to a point sitting on top of this cone. In fact, that's what we have, is we have a cylinder plus a cone. So how would we figure out the volume? Okay. Well, we're missing some pieces, right? So in this case, This was 8 foot. And the entire thing was 40 foot total, with the switch coming halfway. Okay? In addition to this, it has grain in it, but it's not full. We want to know how much grain is it. So we went to our silo and we were able to gauge the depth, and we need to know how much is left in there if it was only filled up 6 foot above the transition. How much grain is in this particular silo bin? Well, we have this top slice. That's this cylinder. And it's not the full 20 foot tall that our silo is. It's only 6 foot tall, but it does have a radius of 8 feet. However, the cone is completely full. And it has a radius of 20 feet, because remember that transition happened at halfway. And it also has a radius of 8 feet. Okay, so to find the area of a cylinder, or not of a cylinder, the area of a circle, we do pi times radius squared. This has a circle as well. It's pi times radius squared. Then we have to multiply by the height or the depth of our grain. Well, here for the cylinder part, we're only 6 foot deep, but for the cone part, we filled up all 20 feet. But because it came to a point, we're going to divide that by 3. Okay, we have written down how to calculate the volume of each. So then we're just going to go ahead and add those things together. And in this case, I'm going to go ahead and type it out completely and round. So we have pi times 8 squared times 6 plus pi times 8 squared multiplied by 20, and that's divided by 3. I have a typo somewhere. Pi times 8 squared times 6 plus nope. I was right. Just double checking. So we have approximately 2,546.78 cubic feet of grain. Now, a reminder that 1 cubic yard remember that 3 by 3 by 3 I did in another video? That's 27 cubic feet. So if I wanted to change from cubic feet to cubic yards, I'd have to go 27 times smaller. So divide that by 27, and we find out it would be approximately 94.3 cubic yards. Why might I want to know that? Well, my truck that I'm hauling my grain to the wherever it needs to go might be in cubic yards. Not always do you get your hauling in cubic feet. Sometimes you find out in cubic yards. So being able to transition between one and the other is really important as well. Okay.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.